Who here is with consensus? Who here has come out and is with consensus? Awesome. And who here thinks consensus is awesome? So in my mind, one of the coolest things about them is they are building a lot of the infrastructure that is going to make Ethereum truly scalable, whether it's MetaMask or Uport for browser and user ID management, all this good stuff. Today, we're going to hear from Chris from Consensus about tooling, so very fundamental things that programmers need to more effectively and easily write programs, and probably a lot more on top of that. So, welcome.
Great. Thank you, Kent. Thanks for all the help with the AV stuff. That was not fun. Hopefully everyone's day is going well. So my role at Consensus is as a backend and smart contract developer. I don't actually work on the Truffle team, but I use Truffle every day in my development practice. So I was going to talk a little bit about what Truffle is, what you can do with it, and then show you some live coding examples, which is why it was so important that we get the computer set up. One of the big things that I think is extremely important, as we just saw with all the security vulnerabilities that are possible with Solidity, is testing, and Truffle helps you do testing as well. So Truffle is a Ethereum and smart contract development framework. It contains tools for compiling, linking, deploying, managing your contracts, automating your testing, deploying and running migration scripts, network management, so keeping track of which contracts are deployed on your local networks, which contracts are deployed on test networks, which test networks they're deployed to, and also installing, running external packages, and interacting with your contracts so you can actually interact with them on your local blockchain. One of the great things about Truffle is that it also comes with boxes. So boxes are pre-made projects. You can start with a vanilla box, completely blank slate, or you can also do a Truffle unboxing to start with a repo that has some tools built into it. I'm going to be using one called Truffle Token today, but for the hackathon, I would definitely recommend checking out the Truffle website for their boxes. They have some React boxes, they have some React Redux boxes that can help you get your project going quickly. So I think jump right into coding. If I can get to the right place and make things. How do we feel about that size? Good? Okay. So, starting from scratch, we are going to make a new directory. And I mentioned the Truffle unboxing command. This is the command for that tutorial token one that we need. While that's downloading, as I said, there are ones for React. There are ones for using React and Redux. Truffle also makes several other tools. The Truffle team makes Ganache, which is a local test blockchain that you can deploy to. I'll show you that a little bit later. And also a new tool that they made called Drizzle, which I don't have any experience with myself, but it handles state updates with React and Redux interacting with the blockchain. So it basically listens to that for you. And as expected, we don't have internet, so when you unbox Truffle box, you get several things, as I said, out of the box. It starts out with a Truffle configuration file. This is where you can configure information for how you want to connect to your networks. For purposes for this presentation, the most important one is just the development network. You can see that we're using the host 127, port 45. I'm actually going to change that to 85 because we'll need that later when I connect to Ganache. Like a lot of NPM projects, it comes with your package.json, which you can set up to run custom scripts and also keep track of your dependencies. It has a basic contracts folder, a basic migrations folder, and also a test placeholder folder. In the source folder for this Truffle box, it has a basic front-end app that if I have time, I'll get into and show you the Web3 interactions that come with this one, but it's a good starter place. That's why I mentioned the React ones earlier. It comes with a React starter app and can get you started on building your React app very quickly. So I want to start with a basic token. Sorry, let me rearrange my windows here. And if you were at the talk earlier this morning about Solidity development, hopefully some of this will look familiar, but just setting up the basic Solidity token contract structure here. And initially, it's not going to do anything for me. So this is a very boring project. We want to use, I'm going to base this off of ERC20. Thank you. If anyone has ever live coded in front of an audience, it is a lot of fun. Your fingers stop working for some reason. The Zeppelin, Open Zeppelin people presented earlier, and I also want to utilize their Open Zeppelin contracts for this because I'm building an ERC20 token. Since I don't want to rely on the internet, I have already installed those modules under my, in this project when I set it up. So I can simply import those contract, or the ERC20 contract here. And then inherit it in my contract. I want to set this contract up with some basic information about it. And then also create my constructor function to do the initial allocation of tokens. So this total supply that I'm using here is something that I'm inheriting from the Open Zeppelin structure, and I'm setting that to my initial supply that I'm setting in my contract. So the contract, or the ERC20 token is set up. And then initially allocating all of those tokens to the account that instantiated the contract. Get rid of that. So now I have a very basic contract set up. Still haven't really done anything with Truffle yet, so let's get into what Truffle does for us other than setting up the project. As I mentioned earlier, Truffle comes with migrations that we can run to launch our contract and deploy it. So this artifacts.require is, I believe it comes from Truffle, and it basically is allowing it to go back and pull the contract code that I've written into the contracts directory in that file in the same way that you would do an import or require for an npm package. So that should be all the migration code that I need to get a basic contract set up. Truffle compile is how I'm going to compile that Solidity code, if I can type that, and put it into a build directory. So it's going to go through my contracts, run So I said I had installed Zeppelin, and I may not have actually done that. Hopefully that works. So looking at this command and the output it has here, you can see that it compiles my initial Denver token contract. It also compiles a base migrations Solidity contract that comes with the Truffle box, and then pulls in all of those dependencies that I imported from the Open Zeppelin library to build the ERC20 standard token, and it writes those to the build contracts folder that now appears in my project as JSON files. That hasn't done anything yet other than compile those contracts into the JSON objects. So that's where running a local blockchain comes into play. As I mentioned, Ganache is another tool that's made by the Truffle team. It is a local blockchain user interface and will run, you can see that I'm running on localhost here, 8545, which is why I changed that Truffle.js file earlier, and I have a network ID of 1337. So now when I run over to my console, I can do Truffle migrate, and that will launch those contracts onto my blockchain running locally on my computer so I can interact with them. You can see that it runs the migrations that I wrote. The initial migration is the one that comes with the Truffle initial project, and then that deploy contracts is the one that I just set up. And here, it deployed my Denver token contract to, I believe this is the transaction ID, and then this is the address where my contract is deployed. And if we pop back over into Ganache, you can see those transactions having taken place here on the blockchain, creating those contracts and calling them. So now I have contracts living on a local blockchain. With Truffle console, I can interact with those contracts. Truffle console uses uses something similar to what you might find with Web3, if you're familiar with that. So I want to do Denver token.deployed. And we've got a promise, so then result. Sorry, I jumped lines in my notes. So all I did there was I essentially set that instance variable that I set up initially as my deployed contract. So now I can interact with instance as the contract that's running on my local blockchain. And if you remember, I set up the total supply and set that to the total supply variable that the ERC20 interface provides for me. So I want to check what my total supply is for this contract to confirm that we've launched our token, and it's the 20,000 that or 200,000 that I set up initially. I can also check the balance of the accounts that I'm using. So that initial account on Ganache is the one that would have deployed the contracts. That would be this address right here. Which I need to grab without the return. So here I'm calling the ERC20 balance of function. And you'll notice that I'm doing the .call at the end of it. So I'm not actually doing a transaction on the blockchain. I'm just calling the and getting the response. And as I said, when we set up the contract, I allocated all of that initial supply to that first contract that instantiated the contract. So you can see that we've confirmed that contract has 20,000 here. Nothing too interesting, other than we have confirmed that those balances are set up the way we wanted it to, but because we're using the ERC20 interface, we can transfer tokens to other accounts. So let's try that real fast. Actually, I feel like that kind of shows you the functionality of Truffle console. Does anyone want to see blockchain transactions happening on Truffle console, or should I move into Truffle testing and interacting with the Truffle suite that way? Testing? Okay. Because we're using the ERC20 token contract and interface, I don't feel that testing that's really all that interesting. So what I want to do is I want to test something special, something custom that I'm building to this contract. So we set an initial name for the contract, but let's say that someone owns this token contract and they want to be able to change that name. So we want to be able to have, first off, ownership of the contract, which is thankfully another OpenZeppelin standard. So let's import that and get that set up. So now my contract is standard token and ownable. If I wanted to, I could do migrate reset from within the Truffle console here to redeploy that contract, reset the migration, and now I can interact with that contract as though it's ownable. Again, there's not much functionality that we've built in there, so I'm going to exit out of Truffle console and go over into my testing and build some tests. Sorry? I'm not sure about that. I didn't, if I had to recompile the code, or if I can just do migrate reset. I think migrate reset recompiles those JSON objects. Something that I find I do every now and then with Truffle is go through and delete the build folder and recompile to reset things in there. So the question is, if I delete build, would I delete where the contract is deployed on the chain? I don't believe so. I believe Truffle keeps track of that someplace else relative to the migrations. I don't think that's in the build folder. Truffle allows working with two different types of testing. You can do solidity tests or you can do JavaScript tests. Today I'll show you an example of a JavaScript test. So similar to how I set up my migration, I'm going to require that artifact in at the top of my test, and then to interact with it, if you're familiar with Mocha testing, this will probably look similar. So you see here I'm passing in accounts. This will allow me to interact with the accounts that are in existence on the blockchain that my test is running on. And I want to set up a couple of initial constants here for us to use. So my owner is going to be my first account. And then we'll have a not owner account that we'll use later. Kind of similar to how I set it up in the console, I do a let contract equals null, and then later in each of my tests I need to deploy the contract, so I want to be able to set that contract to the instance that gets deployed with each test. And here, instead of using promises, I'm doing async and await because I find that to be a little bit cleaner syntax. Similar interaction from what you might be familiar with Web3. I'm just creating and deploying a new contract in the test before each test runs, and I'm saying this is from the owner account. So that will set that owner account as the owner when the contract gets instantiated. Now I'm practicing a little bit of test-driven development here because we haven't actually written the function change name, but we know that it should allow the owner to change the name, the token name. Okay, so what we have here is a simple test that should call the contract, get the original name here on the current name, or no, I'm sorry. We're going to set a new name, and then we're going to call the contract to change the name from the owner account to this new name. So here's my contract instance, here's the function that we're going to write, change name, and here's the value that I'm passing in. I want to call this from the owner so that it gets past the only owner modifier that will add into that function later. Then we call the same contract to get the name variable, and we assert that the current name equals the new name, proving that we have changed that contract. So if I run Truffle test right now, this would fail because the contract does not have this function built into it. So let's go add that function into our contract. So I switch back over to, nope, sorry. Just trying to give us a little more space here. Here we go. Okay, so back into our contract code here. We want a change name function that accepts a new name. We want it to be public. We want only owner. Because we're inheriting the ownable contract, we have that modifier available to us from the Open Zeppelin contract standard, and we're going to return whether or not it was successful. And this is a very simple function. We want to take the contract name and set it to the new name that is getting passed in and return true. So now that is built into our contract. We should be able to switch over to our console and run Truffle test. Now, as I said before, the Truffle test is not dependent on any local blockchain. or I'm sorry, it is dependent on a local blockchain. So if I didn't have Ganache running, I would get an error saying it couldn't find test RPC. But it is not dependent on the contracts already being deployed on that blockchain. It will deploy the contracts themselves. Now we get to play a little bit of... So I passed in accounts here, but forgot to use that. See if that works better for us. So you can see the test suite initially compiles the contracts and deploys them, and then just like your Mocha tests runs them, we get one passing test. It should allow the owner to change the name. Great. Now we know that our function's doing what it's supposed to do on the happy path, but on the sad path, what happens if someone other than the owner tries to change the name? Let's write a real quick function to test, or a real quick test for that. Because I think it's very important, especially coming right after the security talk, that you think about how to test bad things happening in your contract and make sure that your contracts protect you from those bad things from happening. So we're going to need to throw an error message. Let's set that up here. So this would be if the non-owner was allowed to change the name. And we're going to have a new name again. And we want our original name to equal what the contract gets called with, or gets instantiated with. Now we're going to try to change the contract name from the not owner account that we set up. So this is going to be our second account that gets passed into our test. And I'll come back to this line once I get the rest of this built out and explain what that's doing. I also need to add that function in at the top. So I said I'd come back. We need to write a isEVM exception function up here that's going to test if we're throwing an EVM exception. So all this is doing is taking the error that gets passed into that catch block and checking to see if it includes the word revert. If our contract fails for some reason, it's going to include that revert back to our test suite because the Ethereum or the smart contract kicked it out for whatever reason. In this case, because it was not the owner that was sending it. So we try to change the name. If there's an error, we're going to end up in this catch block. Pass that error into our isEVM exception function to check if it contains the word revert, because then we know that it's not some I misnamed a variable or JavaScript error, but rather an EVM exception. If it's not, then we still want to double check to make sure that something hasn't happened. So we're putting some extra safety boundaries around our test here. So I'm going to get the current name and make sure that the current name does not or still equals the original name. And if it does, then we're going to return. If not, then we want to make sure that we don't somehow end up at this part of the test, so we're just asserting false and then passing in that error message that I set up here is not owner was allowed to change the name, because then the name will have changed at this point. So let's see how many typos I have in this test. So we do have a failing test here. In the output of that, I'm seeing an assertion error and that it doesn't trigger a solidity revert statement. Did anyone spot that I made a typo along the way? Can point me in the right direction? So most likely I have a typo somewhere in here that I have a JavaScript error, sorry. The error message is that the assertion error status for the code, that is right here. Thank you very much. In my notes, I didn't have the curly brackets, so I didn't have a return statement. So that was the problem. For those of you not familiar with ES6 syntax, without these, this statement automatically returns. With those, you need to put in the return statement, otherwise you get strange errors. So that's a very basic, how do you use Truffle to start a project, write your code, deploy it to a test blockchain network, interact with it through the Truffle console, and then write tests. I think Truffle is a really, really great tool. It's something that, especially around the testing, I use every day. I think it was a really great way of getting you started for your projects for this hackathon. And I am not entirely sure when my talk was supposed to end, but that's kind of the end of the coding piece. If there are any questions, I can try and answer them. I should be floating around all weekend for any questions that you have while you're writing stuff, yeah. So the question is that in some solidity coding patterns with contracts, you can use shell contracts or proxy contracts is how I've heard them called before. And whether or not Truffle has a way of managing that for you and helping you keep track of those contracts. Honestly, I'm not sure. In the Truffle documentation, it says it helps you with linking contracts together and also helps you with libraries. So I think it probably does, but I haven't dug down to that point. Yeah. Thank you. I had lots of prep. Yeah, I'll be floating around this weekend. I also have some resources for you that I meant to show at the end. There's a little bonus in there of Sol Hint, which is a linting and hint tool that you can use to check the quality of your code. It looks for problems, looks for some security issues. I'll see where I can post these. There's a really great video tutorial that I built or based a lot of this off of that was done by the Truffle team, by the experts, that probably had a lot more smooth coding than I have. But yeah.